Okay, so Bright Stars, a private secondary school, is considering launching an A-level stream in the school. The following information reads the decision. The directors of the school consider that the enrollment in the A-level could be low, moderate, or high with probabilities of 0.3, 0.6, and 0.1 respectively. The directors of the school could either do nothing, build a small school, or build a large school to cater for A-level students. Due to the nature of the students and the likely reaction of competitors, the decision taken by the director is considered irrevocable. The directors have requested the research manager to present estimates on the present value of estimated profits with respect to each decision taken and the various states of nature. The research manager has presented the following data. So we are given the decision of doing nothing, building a small, and building a large school. One of the directors has suggested that Bright Stars could hire a consultant at a cost of 25 million. The consultant would carry out a market survey and report on whether demand for the A-level stream would be poor, reasonable, or good. The director has been presented with the following conditional probabilities based on the previous surveys carried out by the consultant on behalf of the school. So we have that. So you are told to get the optimal decision, and then the optimal decisions, you advise the director. Now that question is on that question of May 2014 is on decision making. So as we say, the very first thing is to know what is the objective. And as you can see here, the objective is obviously to make profits. Yeah. Then the next thing is to know what options are available. And options, we say they are within control. So these guys, they have three options. The first option is they can do nothing. The second option is that they can build a small school. And the third option is that they can build what? A large school. That is according to information 4. But when we come to information 5, we are told that they are thinking of hiring a consultant. So that introduces another set of options, whereby they can say, we will hire a consultant, that is they hire, or they don't hire. They don't hire what? A consultant. Now, if they don't, maybe I start here, if that is do not hire. If they hire the consultant, according to the information 6, will give them 3 types of reports. He can tell them the report is poor. He can give them a reasonable, and he can give them what? A good report. You don't want to chew. Haya, so tuendelee. You're making noise. Haya, so tulikuwa tumefika hapa that we will be given those three reports. Now, whichever report comes out, these guys will have to decide on three outcomes. Sorry, three options. Now, for each one of these, do nothing, build small or large. Nothing small, large. Nothing small, large. Now, for each one of these, there will be three outcomes. You will either get low, moderate, high. Low, moderate, high. So this is how you count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 3, that requires 36 steps. See, there are 12. Each one of them is going to generate 3 more. So we need 36 steps. Okay. Alternatively, if you don't want to grow that tree, you don't want to grow that tree that way, the probabilities okay. So you have to do a tree that is 36 steps. Are we okay with that? Okay. So sijui kama my whiteboard itakoshare. So those are 36 tails. 12. That is how the tree will look like. So this is where we are saying to hire. So there is an expert, and here there is no expert. And this expert is being hired at a cost of 25 million. So 25 in a while. Then he can give us a report that is poor or reasonable or good. Whatever we decide, we can do nothing, or we can build a small one, or we can do a radio. We can do nothing, small or large. Nothing, small or large. Nothing, small or large. The outcomes are low, moderate, high. So we can use the first letters: low, moderate, high. Low, moderate, high. Low, moderate, high. Low, moderate, high. This fast. Has to be growing. Just growing for visual purposes. Sketching. Not yes. Actually, sketching too much. Too much. I'm not too much. Visione fisico. Noi abbiamo c'è dietro let's see, man. Mira, claro,
The first part.
Okay, so let's record the probabilities. Now, if you look at the probabilities of the poor, you can see poor is giving us, if you look at that contingency table, you add them, eh? It is 0.9. You see that? If you add the column, then reasonable, if you add, you get 1.1. Eh? Then this other one you add for good, you get what? Yeah. So I told you what to do if they are. So first of all, if you add all of them, they will give you what? The 0.9 plus 1.1 plus 1, that is what? 3. So if it is 3, you divide each by the total so that you get the probability of 1. So 0.9 you divide by 3, you get 0.3. Is it?
0.9 divided by 3.
0.3. Okay. This other one, the reasonable, if you divide the total by 3, you get 0.37. So if it goes without saying, this must be 0. What? 33. Then that is now what we call the Bayesian theorem. And what you do now for the poor, when we go to the poor, you will be dividing each by the total of the poor. If you remember your knowledge on the contingency table. So 0.8 divided by 0.9. So 0.89. Eh? So for the row it is 0.89. So kila mahali kuna row kwa poor 0.89. 0.89. That is for the poor. Then for the medium, 0.1 if you divide by 9, that would be 0.11. Eh? This would be 0.11, 0.11. And obviously for the rows, it is 0. Yeah. Or rather for the high, it is 0. For the high, it is 0. I do the same for the reasonable. 0.1 divided by 1.1. 0.09. Those are the rows. 0.09. Tuende kwa hiyo ingine. 0.8 we divide by 1.1. 0.73, that's the medium. 0.73, 0.73, and 0.73. So what remains for us to get 1? 0.09 plus 0.73. What remains for us to get 1? See, to divide. We are still dividing by 1.1, or alternatively, you check what remains for you to get 1. 0.18. So 0.18, 0.18, 0.18. Now for good, because they are adding to 1, those ones there is no, even if you divide, it is still going to give you that. So it is 0.1.8. So 0.1.1.8. 0.1.1.8. Tukikuja kwa no expert, you go with the probabilities that were given up there. Zero information 1, which was 0.3, 0.6, and 0.1. 0.3, 0.6, and 0.1. 0.3, 0.6, and 0.1. What is that? Let us record the payoffs. When you do nothing, the values are zeros. So hapa utaweka 0, 0, 0. But if you do small, you get minus 100, followed by 300 and 300. If you do large, you get minus 200, followed by 200 and 800. If you do nothing, 0, 0, 0. If you do small, it is minus 100, 300, 300. If you do large, it's minus 200, 200, and 800. Do nothing, 0, 0, 0. You do small, this is minus 100. We have 300, 300. Large is minus 200. This is 200, and this is 800. You do nothing, 0, 0. Small is minus 100, 300, 300. Minus 200, 200, 800. So this is what we are going to do. Hatutaandika ile maneno huwa tunaandika ya computation, we just do it in the card straight. Tulisema you multiply these probabilities with the payoffs. So for the first one, this one at mode 1, it will be 0.89 times 0 plus 0.11 times 0 plus 0 times 0. So the answer is 0. Now just come and write somewhere here. That is also a way of writing those EMVs. If you have a different color, you can use still very good. Alright, let's go to number 2. Number 2, utasema 0.89 times minus 100 plus 0.11 times 300 plus 0 times 300 equals negative 56. So unaandika hapa juu ya number 2 negative 56. Tuende kwa hii number 3. 0.89 times minus 200 plus 0.11 times 200 plus 0 times 800. Tumesema 0.89 times minus 200 plus 0.11 times 200 plus 0 times 800. Negative 156. Tukuje kwa number 4. That one obviously will be 0. Tuende kwa number 5. Tuseme 0.09 times minus 100 plus 0.73 times 300 plus 0.18 times 300. Positive, 264. Haya, tuende kwa huyu number 6. 0.09 times minus 200. 0.73 times 200. 0.18 times 800. 272. Tukuje hapa, this is 0 obviously. Number 8. 0.1 times minus 100 plus 0.1 times 300 plus 0.8 times 300. 260. 9. 0.1 times minus 200 plus 0.1 times 200 plus 0.8 times 800, you have 640. Do the same for number 10, but your answer. That is 0, obviously. Number 11. And 80. The last one. 140. Okay. Haya, turudi sasa kwa number 13. Number 13, you can see the lines going out are incomplete. So hii ni kuchagua. And I told you we go for the highest. So tunachukua hii 0, hii minus 56 na hii. So the highest ni 0. So hiyo 0, kwanza una mark hivyo because that is where we have selected, and then you write your 0 here. Write your 0 there. Kuja kwa number 14. Again, we go for the highest there, which is 270. Na inapatikana hapa kwa rank. So kuja hapa uandike 272. Ukikuja kwa 15, the same argument. Tunachukua 640. Naandika hapo. Ukikuja kwa number 16, tunachukua 180. Hiyo ni a small. 180. Tuende kwa number 17. So number 17, because it is complete lines, we have to multiply. So tutasema 0.3 times 0 plus 0.37 times 272 plus 0.33 times 640. But you can see there is a cost here, so subtract this 25 from that answer. You subtract this 25 from the answer, you get what? 286. 286.84. Nimesema 0.3 times 0 plus 0.37 times 272 plus 0.33 times 640. You say equals, then you subtract 25. Yes. Okay. Therefore, we come back to number 18 here, which is a case of selection. Because you can see these are incomplete lines. So to angalia here 286 na here 140. So we go for the 286. So the advice we offer to our friend is that he should go for the expert. So the advice you shall say like this. Go for the expert. Very happen here on your own. Go for the expert. And if he gives you a poor report, you do nothing. If he gives you a reasonable, you build right. If he gives you a good report, you also build right. So that's the advice to guide them. That's okay. Yes, the costs. Usema kama kuna cost hapo you are supposed to subtract. Okay, so that is fine. We proceed to the next question, which is December 2017, question 2B. December 2017, question 2B. Tuko sawa? So in that question of December 2017, question 2B, we are told a company produces two types of electric components whose information has been provided to you as follows. So we have the mean, the standard deviation, and the sample size. Determine whether the quality of the two types of electric components differ significantly. And you use a significance level of that percent. So as usual, you must know, is this question about hypothesis testing or confidence interval? What do you think it is? Is hypothesis testing? And then, if it is hypothesis testing, if the question is hypothesis testing, I told you you must be able to also know whether the population is known or unknown. So the question is on hypothesis testing. So is the population known or unknown? Why? Of? So when you're given the standard deviation of the population of the sample, the population is unknown. The population is unknown. It is only when you are given the standard deviation of the population that you say it is known. And I have kept on insisting, it's not just seeing the standard deviation, but with standard deviation. The second thing is it one sample or two samples? These two samples. Question is on two samples. And the last thing you must establish is which value are you dealing with? Is it the mean or the variance or the proportion? It is the mean. The means difference. So I have said that it is not just about the standard deviation, but it must be the standard deviation of the population. The one that we were saying is presented by this side. So when you see this, that is when you say it is known. But come the standard deviation of the sample and hakuna population, then that population is unknown. Vera, I hope that is clear. So from there, you now bring the hypothesis. You now bring the hypothesis because this examiner has already computed for us the values that we require. So in the hypothesis, the null hypothesis, we say x bar 1 is equal to x bar 2. That is, the first sample has a mean of what? 1600. Now we are bringing a 15. 28. 1528. The alternative, we will say x bar 1 is bigger than x bar 2. That is 1600 is something bigger than 1528. It's bigger. Haya, kutoka hapo tunakimbia the second step, which is called significance level. Significance level. In the significance level, alpha, we are already told it is 5%. Because we are told to do at 95. Haya, safari inaendelea, tunafika step 3, where we say test statistic. Now, in the test statistic, we normally say T is equal to what? Can you recite that formula? It is x bar 1 minus x bar 2 square root of n1 minus 1 s1 squared plus n2 minus 1 s2 squared. This one is first of all divided by n1 plus n2 minus 2. Hii unafunga kwa brackets namna hii, then unasema times 1 out of n1 plus 1 out of n2. You have not registered these in the memory. So T calculated. T calculated. You now substitute these values. Where you see this is 1600 minus 1528. And 1 is 120 minus 1 multiplied by 132 squared plus 110 minus 1 multiplied by 149 squared. So 120 plus 110 minus 2. 1 out of 120 plus 1 out of 1. So work that out and give me the answer. Division of populations not a sample. Number 6.
It's gonna be standard
Division of population.
or
Number 6. After S.
yeah, we need the X.
The sample.
Sample is there.
So the shoe. Thank you. Near the 3.8. James, with 43. Better than 43. Happy? Before square root around. What?
0.0.
I mean, 3.8. It's 8. Unapata that is 343 3 lines. So I mean, and then you put it then square it. So you get 18.53. Then 18.53, you get 72. You get Answers number.
How is it really? Maybe a button cry. Okay, I come and
Anyway, my guy, I'm sorry.
in the very one
This is my name. Miss.
What is the answer? 3.89, Vera has 5.27. Okay, 3.89 appears to be the most popular. So Vera, you confirm or you have revised that? Good. Revised that. From there, we now do what? The next step is called decision rule. In this decision rule, the degrees of freedom will be 120 plus 110 minus 2. That is 228. 228. And this one is one tail. Is one tail. Is a one tail decision rule. So kama hiyo ni kweli, tunakuja hapa, we draw something smart like this. Because we said higher, so this is positive T critical. You find yourself above here. We will say reject null at 0.05. But upper, we will say accept null at 0.95.